Hello, everyone. My name is Haron Peña, and today I'll be sharing about the role of repeating and growing patterns in pre-K through second grade mathematics. This presentation is based on the work of Blatten and the Module 2 lessons that we were assigned this week. Let's go ahead and explore how these early patterning experiences help our students develop foundational algebraic thinking. So, when we think about algebra, we often imagine variables and equations. But for our youngest learners, algebra begins much earlier. It begins with patterns. Patterns allow children to recognize structure, allows them to describe relationships, and predict what comes next. In this short presentation, I'll explain how repeating and growing patterns support early algebraic reasoning and give examples you can use in your classroom. We begin with an overview. According to Kaput, the heart of algebraic thinking is building, expressing, and justifying mathematical relationships. When students notice and describe patterns, they're developing exactly that kind of reasoning. They begin to see how numbers and shapes relate, forming generalizations long before they ever use variables like our very famous x or y. So, why do patterns matter? Working with patterns helps students build algebraic reasoning and they begin to generalize, justify, and communicate ideas, which is vital in learning algebra. It also supports their understanding of how numbers change and relate, forming the base for future works with functions and variables, for example. As Blanton emphasizes, all children can learn to think algebraically when our classroom fosters curiosity and communications effectively. The first pattern that we encounter is our repeating pattern. What is a repeating pattern? These are sequences that repeat in a predictable cycle. For example, red, blue, red, blue. The goal is for students to identify the part that repeats, which is what we call the unit of repetition. It might be an AB pattern, like colors, where we compare two different items, or an ABC pattern, like triangle, square, rectangle, which is three different things. Recognizing this structure helps children make predictions and talk about patterns logically. So, we can talk about this example here, which is in an A-B scheme. So as children become more confident, we can help them connect pattern elements to their positions. So for example, if position A1 is red and position 3 is also red, they can start to see regularity in the patterns. We can also ask, well, if position 7 is A, but with position 10 B? These kinds of questions build logical reasoning and it prepares them to think about relationships in algebraic ways. Our second pattern is our growing pattern. So, contrasting repeating patterns, these shows a constant change or growth between each step. So, for example, counting 1, 2, 3, 4, 5 shows a pattern that grows by 1 each time. Or counting by 5s, 5, 10, 15, 20 shows growth by 5. We can also show this visually, like using blocks that increase in number each step. Students begin to describe this change in words and eventually in symbols, which is a key part of algebraic thinking. So here's an example of growing patterns. So step one, there is one block. Step two, there are two blocks. Step three, there are three blocks. Step four, there are four. And step five, there are five. So students can describe the rule as the number of blocks equals the number of steps. Or for each term, we add one block. So there is an early intuitive way of expressing a functional relationship, just like in a basic equation. So the connection is important. In the classroom, what are our expectations and the outcomes for our students? So we might give students colored cubes, beads, or pattern blocks, whatever manipulatives you want to use. We should be asking open-ended questions like what comes next? How do you know? What is changing each time? These questions encourage students to explain their reasoning, not just identify a pattern, but help them connect what they see to mathematical rules, which is super important. It is the foundation of algebra. So these skills prepare students for abstract algebraic concept in later grades, which is the goal. To wrap things up, repeating patterns help children recognize cycles, while growing patterns help them describe change. Together, they form the foundation of algebraic thinking. By exploring and describing patterns, students begin to reason mathematically long before they encounter formal algebra. I want to thank you for taking the time to watch this presentation, and here is our references to end our presentation. Thank you very much.